So here are the notes for 5.8 Day 2 notes. Here we're going to once again use our graphing calculators to graph polynomial functions, as well as find the domain and range of polynomial functions. Now let's talk about domain. Remember, domain are all your possible x values. So that's dealing with your x-axis. For every single polynomial function, the domain will always be negative infinity to positive infinity. So make sure you make note of that in your notes. So it will always be negative infinity to positive infinity, no matter what type of polynomial function you have. Now let's talk about our range. Well, range are the possible y values that deals with your y-axis. Now this is where it's going to differ depending on your degree of the polynomial. If you have an odd degree, remember that means your highest exponent is like 3, 5, 7, anything like that, your range will be from negative infinity to positive infinity, just like we did with domain. However, if you have an even degree, so remember your highest exponent is either like 2, 4, 6, 8, etc. Now this is where we're going to have a little bit of different range here. Now if our leading coefficient is positive and we have an even degree, meaning that our arrows are going up if we're graphing this function. Okay, so this is our end behavior of our polynomial graph. Basically how to write it is we're going to use a bracket. We're going to go from the local minimum and then we go to positive infinity. Okay, now for your local minimum, basically what you want is the smallest local minimum. Or really, another way of saying this, we want the smallest y value. And then we're going to go to positive infinity. Now if your leading coefficient is negative, meaning that for your graph, the arrows are facing down, okay, we start from negative infinity. Remember, infinity signs we use parentheses. Then we go to the largest local max, or basically the largest y value. So make sure you watch out for that. Okay, let's go ahead and graph our first function. We're going to use the x-intercepts to graph the function, but we're also going to find the local max and minimums using our graphing calculators. Now here's our function. We have f of x equals 1/6 times x plus 3 times x minus 2 squared. Now notice how this function is written. It's actually written in factored form. This actually allows us to find the x-intercepts a lot easier. So we don't really need to use our graphing calculator to find the x-intercepts. Now before we find any of the points, what we need to figure out is our end behavior, meaning which way do our arrows face. The first thing we need to figure out is the degree of the function. Now remember, if we are in factored form, to find the degree of the function, we add up the exponents on each of our factors. So on x plus 3, notice that this exponent is 1, and then on the x minus 2, the exponent's 2. So we add these two up and we get 3, which 3 is an odd number. Now we talk about our leading coefficient. Remember, the leading coefficient is the number in front of our parentheses. In this case, it's going to be the 1/6. Since 1/6 is a positive. So now we know that we have an odd degree and our leading coefficient is positive. Our arrows are going to go from down to up. Okay. And we'll actually know this when we graph the function. Okay, our next step is we're going to actually find the x-intercepts. Here, once again, as I said, we don't need to use the graphing calculator because we are already in factored form. So all we need to do to find the x-intercepts is set each of our factors equal to 0 and solve for x. Our first one is going to be our x plus 3. Set that equal to 0. And so we get x equals -3. So that's one of our x-intercepts. Now we do the same thing for the x minus 2. We set that equal to 0. And we get x equals 2. Okay. So our x-intercepts are at -3 and at 2. Now our next thing is we're going to find the local max and the local minimums. Now to do this, we do actually have to use our graphing calculators. So we're going to go ahead and plug this function into our graphing calculator. And remember to do that, we are going to go to the y equals button. So we press the y equals, and then in y1, we're going to put into our function. So we have 1/6. Now because this is a fraction, I'm going to do parentheses 1 divided by 6. Okay. Now our next step is we're going to put x plus 3. So I do another parentheses, then I put x, then a plus 3 in the parentheses. And then lastly, I do x minus 2 squared. So again, parentheses, we have an x minus 2. And because we squared, make sure you press the x squared button. Okay. Now, our next step to graph is we're going to see if we can see our entire graph in our standard mode, our standard window. To find our standard window, we're going to go to the zoom button that is on the first row right in the middle. So you're going to press zoom. Then we're going to go down to where it says Z standard to number 6. Okay, so we can arrow down all the way there. And then we're going to press enter. There we go. And as we can tell, right, well, we can actually see the entire graph. So we don't need to change the window anymore because we can see it. And as well, notice how our arrows go. We have a down arrow and an up arrow. So we did our end behavior correctly. So now what we're going to do is we're going to find the maximums and minimums. Remember, the local max is basically a point at the top of the hill. If we notice here, there is a hill here, and we're going to find this point. This would be one of our local max. Now to find a local max, we're going to go to press second, so the blue button, and then the trace. Okay. Now because we're finding a maximum, we're going to go to number 4. So we're going to down arrow, and then press enter. Now here's going to ask us for the left and right bound. What that means is we want to be on the left-hand side of our max, and then we're going to be on the right-hand side. Now, in order to move the cursor, we can only use the right and left arrows. The up and down arrows do not work at all. So I need to be left bound of my maximum. That means I'm going to have to be somewhere on the left-hand side of this graph. So I'm going to use my left arrow to move my cursor. Okay. Now, it does not matter specifically where the cursor needs to be. It just needs to be somewhere on the left-hand side of your max. Once you've done that, you need to press enter. Okay. So always press enter, because if you don't, then you're going to lose it and you will not do this correctly. Now it's going to ask us for the right bound, meaning I need to take my cursor and put it on the right-hand side of my local max. So remember, I can only use the left and right arrow keys. So here I need to use my right arrow key to move my cursor over. Now make sure your cursor is never on the point, okay, because then it's going to come up with like a domain error or some type of error. Okay, so make sure your cursor is just far enough that it's to the right of your point that you're trying to find. Now don't forget to press enter. Now when it asks you to guess, do not move your cursor at all, okay? All you have to do is just press enter one more time. And then it's going to give you your max. So here, let's go ahead, we'll just round to 2 decimal places. Now when we do our maximum, we do write it as an ordered pair. So our maximum here is negative 1.33, comma 3.09. So we're going to go ahead and write that down on the notes. So our local max is negative 1.33, comma 3.09. Okay. So now we're going to go back to our graph and see if we have any more local max. Because what you want to do is find all of the local maximums. There can be multiple. Now remember, that means we have to be at the top of a hump. Well, if I look, I don't see any more at the top of the hill or over top of the hump. So that means we only had one local max. Our next thing is we got to find a local min. Remember, that is a point that's going to be at the bottom of the hill or a bottom of a hump. If we look here, it seems like this point here is going to be a local minimum because it's at the bottom point or the bottom spot of our hill. So to find a local min, we're going to go to second trace. And we're going to go to number 3 where it says minimum. So down arrow to number 3 and press enter. Now, once again, it's going to ask you for a left bound, meaning where our local min is, we have to be on the left-hand side. So this is where you really need to make sure you know the difference between your left and right. So remember, I can only use the left and right arrows to move my cursor. Now, I need to move my cursor to the right to be kind of close to my local min here. So notice on this side, this would be considered the left side of our local min. Okay, now remember, don't get the cursor right onto the point because it's not going to work. Be kind of close to it. Then you press enter. Now to be right bound, I need to move my cursor somewhere on the right hand side of that local min. So I'm going to continue using my right arrow to move my cursor over. Okay, and then I'm going to press enter. Don't forget, you got to press enter one more time. Okay. So here we have, and remember we're going to round to 2 decimal places. It looks like 2.00, so that's just 2. Now this is going to look a little bit funky. Some of you probably didn't get this. You might have gone something else, or you got mine 0. That is fine. When we are finding our local max and mins, and even our x-intercepts, we are always approximating. So basically the calculator is trying to get as close as possible. Now if you ever see e to the negative something power, all that really means is that this number is very, very close to 0. And so all you have to do is just remember, okay, that here, because it looks like this is an x-intercept, that the y value is just going to be 0. Okay, so whenever you have e to the negative whatever, just make sure that's just 0. So our minimum here is 2, 0. And remember, we have to write that as an ordered pair, so please do not forget that. Same thing kind of with your x-intercepts, which I'll go back to do. Your x-intercepts should also be as ordered pairs. So I'm going to go ahead and do that. So we had -3, 0, and 2, 0. So make sure you write your x-intercepts as ordered pairs. And so for your local mins and max. So here this was 2, 0 as well. Now we're going to go back to our graph one more time just to see if we have any more local minimums. So remember, that means it's the lowest point. If we look, it does not seem like we have any. So that means we only had one local minimum. Make sure you find all max and mins, which we're going to see that in the next example. Okay, the next thing is we're going to sketch our graph, meaning we're going to plot each of the points that we found. So we have -3, 0. So 1, 2, 3, plot a point. And then we have 2, 0. And then here you kind of just have to estimate. So -1.3 is kind of right in the middle. And then up 1, 2. And I would say right here, 3. Okay. Now, one thing I will want to say, use your graphing calculator to figure out how the graph looks. Okay, use that as a resource. Don't be like, oh, I don't know how the graph's going to go. Just look at the graphing calculator, and it tells you. So remember, we have an arrow at the end. We come through our x-intercept of -3, 0. Then we have a local max, come down at our x-intercept and local minimum, and then come right back up. So I'm going to draw this exact same type of graph here. Okay. And notice that for our end behavior, we also have those arrows. So we started from down. We're going to go through our x-intercept. Then here was basically our maximum. Then I come down to my x-intercept and local max, and I go straight back up. Okay. So if you ever don't know, like, well, I don't know what the graph's going to look like, just use your graphing calculator. It will show you what it will look like. Okay. So then here is our function. Our last bit that we need to do is find the domain in range. Now remember, from the last slide, domain of every single polynomial function is from -infinity to +infinity. And remember, for range, if we have an odd degree, then our range is also -infinity to +infinity. Remember, we found the degree when we were trying to find the end behavior, and since our degree was 3, which is odd, that does mean that our range is also from -infinity to +infinity. And then that's how you graph a polynomial function and find the domain and range when it's in factored form. So our next example, what we're going to do is actually do the same things, but now notice the type of form that our polynomial function. It is actually now in standard form. Because it's in standard form, we will have to now use the graphing calculator to find both our x-intercepts and our local mins and max. So this is kind of like what we did in our 5.8 day 1 when we did our left and right bound. Now, before we find our x-intercepts and local max and mins, what we need to do first is figure out the end behavior of our graph, meaning which way do our arrows go, okay? So to do that, we need to figure out the degree of our function and the leading coefficient. So our function here is we have x to the 4th plus 6x cubed minus 4x squared minus 24x. Notice that this function is written in standard form. Remember, standard form means that we go from the highest exponent and we decrease from there, which we do. So our degree, it looks like, meaning that our highest exponent is going to be 4, meaning that our degree is even. Now we got to figure out the leading coefficient. That is the value in front of our first term, our x to the 4th. In this case, our leading coefficient is 1. Remember, if you don't really see anything there, that means it's 1, not 0. So our leading coefficient is 1. That means it's positive. Since we have an even positive, our arrows are both going to go up. Now remember, all of this was from our very first section of this unit when we had to deal with end behavior. So if you don't remember, make sure you go back to 5.2 day 1 to get all this information. So this is really just a lot of review, especially the end behavior. Okay, our next step is now to find the x-intercepts. Now to do that, we need to plug our function into our graphing calculator. So go back to your graphing calculator, and what we're going to do is go to the y equals button. Don't forget, if you ever need to plug in a function, you go to the y equals. Now, this was our last function. What we need to do here is we need to press the clear button to get rid of it total. There we go. So now what we're going to do is plug in x to the 4th. Now remember, anytime you need to do an x or do an x, it's right next to the alpha key. So I press x. My next thing is I need to do the caret key, so it's like this little symbol here, and then we have to the 4th power. Now, if you're doing this on a graphing calculator, which you need to, okay, if you still have this arrow up, this means you're still in the exponent position. So what you need to do to get rid of this exponent position is use the right arrow. If you do not, then you're not going to have the right function. It's going to look kind of wacky. So right arrow over. Now we put in our next term, which is plus 6, and then remember your x, and then to the cube, so caret key 3. Once again, we need to right arrow over, so we're no longer in the exponent position. Okay, then we do minus 4x squared. Do an x. Now here, there's already a square button, so you can use that. And then minus 24x. So what I have up here, it should look exactly like yours on your graphing calculator. If not, that means you need to go back and try to do something so it looks exactly what I have, okay? Okay, now what we're going to do is go back to graph. Now we don't need to do the zoom again and go to the Z standard because we are already in the standard window. So that's what we did from last problem. So all we need to do is just press the graph key. Okay, here we are. Now, as we can see, we do not see the entire graph. What you need to do is you need to make sure that you can see the entire graph on your graphing calculator. If you do not, that means you need to change the window. To change the window, you're going to go to the window button. That's right next to the y equals. Okay. Now, before we do that, we need to make sure we notice what we need to change. Okay, let's talk about the x-axis. Well, the x-axis is only important for when we need to find basically the x-intercepts. Well, it looks like we can see all of our x-intercepts. So I think our x-axis is fine, so we can leave it alone. We do not need to change it. What we do need to change, it looks like, is our y-axis. So we need to change our y-max. So the y-max deals with like the positive side, so we need to change that. And we need to change our y-min so we can see these local minimums down here, okay? So we're going to go down, we're going to go to window. As I said, our x values don't need to change. Now you're going to see an x-min and an x-max. These deal with your x-axis. we do not need to change them. So we're just going to down arrow. Now this, where it says XSCL, that represents your scale, meaning that each of those tick marks represent 1. So it's like 1, 2, 3, 4, etc. We don't need to change that as well. What we do need to change is both our y-axis. So we need to change your y minimum, so that's your negative values, and we need to change your y max, our positive values. So I'm going to go in increments of 10. So that means sometimes it does get really big. Okay, maybe we have to try it a couple of times to figure it out. So my y min, I'm going to go by increments of 10. So I'm going to go from negative 10 to negative 20. Now to do this, all you need to do is you can press clear if you want to, and then rewrite it. So the negative button, make sure you use that, because if you don't, it's going to say an error. So make sure you use the negative. I'm going to do negative 20. And then down arrow, I'm going to change my y max. I'm going to clear that as well. And then I'm going to make that to 20. Now, because I'm making my scale different and making it a little bit bigger, I'm also going to change my y scale. I'm going to go ahead and change it to 2s. Okay, so I'm going to change it to 2. Now, let's go ahead. We're going to press the graph button again and see if we can see our entire graph. Okay. Now, it looks like our y max, remember the positive side, we can see the entire graph, but we still can't see the entire bottom part, our y minimum. So we need to go back to window and change. So we're only going to change the y minimum. So I'm going to go to window. So I'm going to go down to y min. Once again, I'm going to change this to an increment of 10. And if we still can't see everything, then that's when you want to go up by, like, maybe you go more than up by 20s or 30s or 40s or 50s. Okay, so I'm going to change this. So I'm going to press the clear and change this to negative 30 to see if I can see everything from then. So make sure you press the graph button to go back. Well, it looks like we can see still, we see more of the graph, but there's still more parts. That means we need to change our y minimum to be a little bit bigger there. So my window, I'm going to go to y min. I'm going to make this kind of big to see if this works here, okay? So I'm going to go ahead and make this into, let's just say, negative 120. Okay. If you wanted to change it to negative 50 and see if that works, that's also a great idea. If that didn't, then you could change it to negative 100, negative 120, etc. Now, because I'm going so big, I need to change my scale here on my y's. So I'm going to go probably by tens, so we don't have all those little tick marks, because it does get a little bit annoying when that happens. And now I'm going to press graph. Now I can see the entire graph, so that works out. Because I can see the entire graph, now I can find all my x-intercepts and my local max and mins. Now the first step I'm going to do is find the x-intercepts. Now we need to figure out how many there are. Remember, x-intercepts is where the graph crosses the x-axis. So we have 1, 2, 3, 4. So that means we will have to do this particular technique 4 times. So I'm going to go to second, so remember the blue button, trace, and because I'm finding x-intercepts, remember all the other names for it, like 0, I'm going to go to number 2 and press enter. Now I'm going to go from left to right, so I'm going to find this most left x-intercept. Remember, just like with the local max and mins, it's going to ask you for a left and right bound. What we want to do is be on either the left-hand side or the right-hand side of our x-intercept. Now remember, I can only use the left and right arrows. So I'm going to move my cursor all the way over. Now what I need to decide is what is the left-hand side of this x-intercept. That is either going to be above or below. Now what I highly suggest is drawing a line straight through your x-intercept to know what is on the right-hand side and what's on the left-hand side. In this case, the left-hand side is going to be, we have to place our cursor above the x-axis, because that would be kind of, if we continue this line, it would be more and more left of our x-intercept. Now I press enter. Right bound is just going to be the complete opposite. So if you already went to the top, just go below, okay? Now, you want to make sure your cursor is kind of close enough to the x-intercept. So make sure that it's just somewhere close enough. We don't want to put it somewhere over on this side because it will not work. Now make sure you press enter. Don't forget, for the guests, do not move your cursor. Press enter one more time. So it looks like our 0 is negative 6, 0. Okay, so I'm going to go ahead and write that in the notes. Now, I am going to write these as ordered pairs like I did in the last example. So negative 6, 0. Make sure you write all your x-intercepts and all of your local max and minimums as ordered pairs. Now, I'm going to do that again, but with our next x-intercept. So once again, I go to second trace, and I go to number 2 and press enter. Now I need to move my cursor over here to know where I need to put it above or below. So to do that, I have to use my right arrow. Okay, so now we got to determine our left and right bound. Now your left and right will always change just depending on the graph and the x-intercept you're finding. So last time when we found this x-intercept, the left bound was above, but that's not going to be the case for this x-intercept. Now, as I said before, draw a line through your x-intercept to see what's going to be on the left-hand side and what's going to be on the right-hand side. So we drew a line here. It seems like, well, kind of using, this would be our left side. So I'm going to get my cursor as close as possible to my x-intercept, but still trying to be below the x-axis. So that looks be fine. So once I've done that, I'm going to press enter. Right bound is always going to be the opposite. So that means since we had it below, we're going to have it above this time. And make sure it's just a little bit above, okay? Don't put it on the other side. Press enter. Don't forget to press enter for a third time. Don't move your cursor when it's a guess. So it looks like we got negative 2, 0 as our second x-intercept. So what I would like you to do is actually go ahead and just pause the video and find the last 2 x-intercepts on your own. The reason being is I want to make sure you guys know how to use the graphing calculator, okay, because it's very important. So go ahead and pause the video, try to find the other 2 x-intercepts. Okay, so hopefully you guys paused the video, you tried to figure that out. Now I'm going to help you out if you were having trouble. So once again, we're going to go to second trace, go to 0, press enter. Now we're going to find the third one, which looks like here. Once again, now the nice part, this is already a line drawn through it, okay? So it looks like the left-hand side of that line, or left-hand side of the x-intercept, is going to be above. Now I need to use my right arrow to move the cursor, and I'm going to press enter. Now the right bound is going to be complete opposite. So since my cursor was above, I need to put it below. And remember, make sure it's kind of close enough to the x-intercept. Don't put it on the other side of a local max or min, because otherwise you're going to get an invalid message. Remember, press enter your third time, and it looks like we have 0, 0. Now you could probably just telling by the graph, it would have been 0, 0. That's all fine. Okay, so that's our third x-intercept. Now we got to do for our fourth x-intercept. So we're going to do, once again, second trace. Now, if you kind of just do this over and over and over again, it becomes second nature. It's just really making sure that you know how to use those features there. So here, we're going to move our cursor over for our fourth and last x-intercept. Remember, kind of if you're a visual learner, draw a line through the x-intercept to figure out the left and right hand side, or your left and right bound. So moving my cursor, it seems my left bound, or left hand side of the x-intercept, we're going to leave the cursor below the x-axis. I'm going to press enter. Right bound is going to be the complete opposite, so we're going to put it above. And then press enter one more time. And it seems our last 0 is 2, 0. So now that we found our x-intercepts, our next thing we're going to find is our local max and mins. Now, in this case, right, we've kind of already done that with the last problem. So if you want to try this on your own, trying to find the local max and minimums using the features on the graphing calculator, that would be a great idea, especially just making sure that you know how to do it. So if you want to pause the video right now and try to find all the local max and mins on this graph, just to kind of make sure that you understand how to do it, it's a great idea. So go ahead and pause the video and try to find those local max and mins. Okay, so hopefully you tried to figure it out, especially since we did a problem similar just last time. So we're going to first find our local max, okay? So max, remember, that means it's a point at the top of the hill. And if we look, I can see a hill right here, and here's our top. And it looks just from our graph that we only have one local max. So what I'm going to do is go to second trace, and then I'm going to go to number 4, maximum. Now, just like before, it's going to ask for a left and right bound. This should be a little bit easier because all you have to do is be on the left-hand side of your basically local max, and then be on the right-hand side. Now, I have to use my left arrow to get my cursor on the left-hand side. Okay, so make sure it's just somewhere on this left-hand side, not on the local max itself, and then press enter. Right bound, I need to put it on the right-hand side of the hill or of the hump. Press enter, and don't forget, for the guess, press enter one more time. So I'm going to once again round to 2 decimal places. So this is going to be negative 1.06, comma 15.06. So for our max, we're going to write this as an ordered pair, just like we've been doing. So we basically have negative 1.06, comma 15.06. And as we said before, there's only one local max. So our next step is to find the local minimums. Now notice that we now have more than one local min. We have a local min here because that's basically we have a point at the bottom of a hill, and we have another at the bottom of the hill here as well. So notice that we have 2 minimums, so we have to find both of them, okay, because both of them are at the bottom. So once again, what we're going to do is go to second trace, okay, and we're going to go to minimum for number 3. Press enter. I'm going to go ahead and find this minimum first. It really doesn't matter which one you find first, okay. I'll find this one. So left bound, that means we want to be on the left-hand side of our local minimum. I have to use the left arrow key to get my cursor over there. Once I've gotten to the left side, I press enter. Then for right bound, I need to do the same. Move the cursor over and then press enter. And then for your guess, press enter one more time. And as we've been doing, rounding to 2 decimal places, we're going to have negative 5.65, comma negative 110.63. Okay, so make sure you round up there. Okay, so one of our local minimums is we have negative 4 point, go back there, 65, there we go, comma negative 110 point, let's go back as well, 63. Okay. Now we're going to do the same thing to find our next minimum. So I'm going to go second trace, go to number 3, press enter. Now my left bound is going to be somewhere over here. So I'm going to move my cursor. So remember that's on the left-hand side of this local minimum. Press enter. Then the right bound is just on the right-hand side there. Press enter. Then guess, press enter one more time. And once again, we're going to round to 3 decimal places. So we have 1.21 and then negative 22.12. And we're going to write that down. Okay. So now that we figured out all of our local mins and max in our x-intercepts, we're going to plot them. Now notice here that some of these points are going to go off, right, our graph. Now one thing is you could change the window of your graph here. So like we could go by 20s on your y-axis and then just go by basically 1s on our x-axis like we did with our graphing calculator. If you rather not do that, we're just going to put our points a little bit above and a little bit below our graph so we can do that. So first thing, we're going to plot our x-intercepts. So we have 0, 0, and then negative 2, 0, and then 3, 4, 5, 6. And then we also have 2, 0. And then our next thing we're going to plot are our local max and mins. As I said before, they are going to go a little bit off the graph, which that is fine. We can do that. So we have negative 1.06, 15.06 as a max. I'm going to change colors for these. Oh no. There we go. Let me redraw this. There we go. Okay. So negative 1.06 and then up 15. We're just going to assume that's where the point is. And then these other points. So we have negative 4.65. So 1, 2, 3, 4, kind of in the middle, right? And then all the way down. Now make sure this point's a little bit lower than the other minimum that we're going to draw, because this should be the lowest point. 2, 3, 4. So I'm just going to put it somewhere down here. And then 1.21, negative 22.12. So we have over 1. I'm going to go kind of in the middle. And then I'll place this right here. Because we want to still make sure when we sketch our graph that it looks similar to what we have on the graphing calculator. Okay, now if you're still not sure like what everything looks like, use your graphing calculator to help you out, okay? So see how we start with our arrow up. We go through our first X-intercept, we hit the local max, come up, go through our X-intercept, and then a local max, X-intercept, a local min, and then another, okay? So if you need to keep looking back at your graph to see what it looks like, that is all right. So as I said, we can go through the first X-intercept. It's going to look a little wobbly, but that's okay. Then we go to our local min. We come straight back up, go through our next X-intercept, and then we're going to hit our local max. Then go straight through the next X-intercept and go to the local min again. Come back up, go through the X-intercept, and then have your arrows. Don't forget your arrows, okay? So that would be our graph for this polynomial function. Our last thing we need to do is find the domain and range. So domain, remember, for every single polynomial function is from negative infinity to positive infinity. And we always use parentheses around that. But remember 2 slides ago when we talked about range, and I'll kind of go back there. For even degreed functions, your range is going to be a little bit different. If we have a leading coefficient that's positive, then we go from the smallest local minimum, then positive infinity. Or if our LC is negative, then we go from negative infinity to the largest local max. Now notice how our arrows went on our graph. They both went up. That means our LC was positive. So we're going to go from the smallest local minimum using brackets and then go to positive infinity. So our smallest local minimum was right here, and we have to use the y value of our local minimum. So remember that this point here was negative 4.65, comma 110. Sorry, negative 110.63. We want to use the y value of our local min. Don't use the x, use the y. So our lowest y value is at negative 110.63. So we're going to write that first with a bracket. And because our arrows go up, right, then those y values get larger afterwards. So then we go to positive infinity. And then parentheses, okay? And so that's how you find domain and range when you have an even degree. If you still have any further questions, make sure you either email me or come in before or after school. If you do not have a graphing calculator to basically do all of this for especially the homework, what you can go is go to this website, desmos.com. And there, you can basically just do the exact same thing that we did, okay, by graphing and finding the x-intercepts and local mins and max. Make sure when you go to desmos.com on that main screen, you press the red button which says Start Graphing Now. So make sure you press that.